should see a little cloud symbol next to it.
Yeah, I do see it.
Okay, perfect.
Yeah, I guess we can get started. We have pretty healthy crowd now.
Yeah, 22. Maybe just give another 2 minutes while people switch over, but yeah, it'll be recorded.
So I think pretty much everyone know, Rebecca will be talking about schedulers and this stuff. So Rebecca, do you want to share? Okay.
Yeah, I'll share my screen. Okay.
Let's give 1 more minute. I think Philip asked for 1 more minute, so let's give it time.
Sure.
Yeah, or Ethan, do you let us know when enough have switched over?
I have sent the update link to the HANA team.
So meanwhile, I wanted to reiterate the message, like we mean this to be an interactive session. So if you have any questions, you don't really have to hold. You can ask immediately so that we can answer when we are in context, and it helps. Hopefully it helps everyone as well. I think we can get started. Like we are already like 9-10 minutes over. And sorry, go ahead, Robert.
Okay. So I'm going to talk about the scheduler today. There's going to be a code walkthrough. I don't have any slides or anything. And feel free to interrupt with any questions that you have. Hopefully I can answer, or someone else on the call can answer, or we can figure it out together. So the starting place for the scheduler is the SQL query scheduler. We're going to be looking at the legacy SQL query scheduler. There's another class that's just called SQL query scheduler that was supposed to replace this one, but it has a bug that causes it to use a lot of CPU. And the motivation for switching schedulers was that one supports full stage retries with LBM, but since we're not, we're focusing more on Presto and Spark now, we're not really investing in that area. So I was hoping to actually pull that code out before this talk, so I wouldn't have to talk about it, but I haven't done it yet. But I think we will want to pull out that new scheduler and make this one the only one, so that there's only one scheduler to maintain. So the SQL query scheduler gets created, and then it gets created with the different stages. So basically you start with a query plan, you end up with a fragmented plan, and then you want to turn this fragmented plan into something that you can execute. And then, so the main loop here is in here. So when we first create the scheduler, we create these stage executions, which they should basically turns these plan fragments into something that is like with the information that's needed to submit it for execution. And so we can look into this. The stage executions, we start with these section stages. So a section is basically a set of stages that have only like streaming exchanges between them. So for a regular Presto query, there's going to be one section. But if you were using materialized exchanges, then you'll have a series of sections, and each time you materialize an intermediate result, then that's going to start the next section. So that's what we mean by section executions. And then the section. So we create these stage executions from the section, from within each section. And then for each stage, we create a specific scheduler for that stage. And that stage is going to be yeah, so the stage, it depends on what kind of stage it is. So there's stages that have only that are doing table scans. So those are usually source distributed. And then there's intermediate stages, you know, where you're doing some kind of join and you have like a hash exchange between them. And that's going to be that's going to have these like fixed count number of nodes. It'll use the number of it'll use as many nodes as the hash partition count. And then you'll have also a scaled writer distribution, which is used during writing, basically to prevent small files. Are people able to see my screen?
Yeah, we can see it.
Oh, okay. Okay.
Mhm.
So we have these different kinds of stages. So if you have a basic table scan stage, then you're going to be using this source partition scheduler, which basically you can see basically when you tries to get the number, it will randomly assign splits to different nodes. Let's see where I can find that. Schedule. There's all kinds of grouped execution code that isn't relevant quite yet. Okay, I'm not going to go into this quite yet, but basically the source partition scheduler schedules for the table scan stages that this code, this if block is for ones that aren't using like bucketing or grouped execution or anything. It's just like a regular table that doesn't have any special partitioning to it. Then the splits will be placed dynamically, just depending on what nodes are available. And it will use as many nodes as the max tasks per stage. For the scaled writer distribution, that's like if you're doing a table write, and then we have a special a scaled writer scheduler, which will start with only scheduling to a few nodes. And then if the buffer is overutilized, meaning that it's writing a lot of data, that it'll start scheduling to more nodes. And that way it prevents, it allows you to have enough parallelism for if you're doing a lot of, if you're writing a lot of data, but it prevents small files if you're actually just writing, a very small table. So that's this scaled writer scheduler. And then here we have this sort of complicated bit of logic. This is mostly for grouped execution. So if the split source is not empty, that means that it has a local source, like a local table scan or something. But it's not, but it wasn't in this basic source distribution partitioning handle. Then we look at the partitioning and we check if it's using grouped execution or not. We get the bucketing. And then we create this fixed source partition scheduler, which is basically for a table scan that has some kind of special partitioning to it, which means that it can't just randomly assign that it can't just randomly assign the splits, but it's going to be based on some specific partitioning. And this was it? And this also, so this will also take into account if it's doing grouped execution, it will definitely go through this code path. And also sometimes if it's not, if there's some special partition. And then if it's using recoverable grouped execution means that if one task fails, that it will retry that task on a different, not if like one not a task, like if a task fails, it will retry all of the buckets that had run on that task on some other task. So that's recoverable grouped execution. So this is adding the specialized logic to support this recoverable grouped execution. And then finally, we have this case where all sources are remote. So this is an intermediate stage. And in this case, it will use the fixed count scheduler. Or actually, it could be also an output stage where, or some other, where the, there's only one task. But often it'll be like in an intermediate stage, if you're doing like a join and you have a hash distribution, or if you're doing a union or something, and then you're going to be using this fixed count scheduler, and the partitioning it might be, a hash partitioning, or it might be round robin or something. And it's going to schedule the number of tasks, usually the hash partition count, but I guess it depends. So that's basically how we decide how each particular stage is going to be assigned to a specific, how its tasks are going to be assigned to specific nodes, or through these different kinds of schedulers, depending what kind of stage it is. So if we go back to the scheduler, we've created our stage executions, and now we can enter the main scheduling loop. So the main scheduling loop, we start with our we get the sections ready for execution. The sections ready for execution means that any previous sections that it depends on have finished. So if there's only one section, then it's automatically ready for execution. If there are multiple, you'll start with the leaf sections, and then as those finish, you can pull in other sections to schedule them. We get the stage executions from each section. And then we create the execution schedule based on the execution policy. So the execution policy, there are 3 different kinds of execution policies. So there's the adaptive execution policy, the all-at-once policy, and the phased execution policy. So all at once means basically schedule tasks eagerly, like schedule all the stages at the same time. The phased execution policy means schedule basically only as many stages as are needed, and then schedule the rest. So for example, if you're doing a union all, it might schedule like one whole like subtree of the union all, and then when those start to finish, then it'll schedule the other tree of the union all. So that means you won't have one query that's just suddenly like eating up all the resources on the cluster, and at the cost of some latency for the cluster for the query. So those are basically the 2 different policies, and then the adaptive policy is kind of like a hybrid. So it's pretty simple. And basically, if the query has a small number of stages, it will use the all-at-once execution schedule. And if it has a large number of stages, then it won't do this eager scheduling. It'll do these phased execution schedule. The all-at-once schedule is very simple. It just adds everything all at once, and it does return specific. Let's say get preferred order. Just make sure that you don't end up in like a deadlock or something. The phased execution schedule is pretty complicated. In sort of this creating this graph where it figures out what it can schedule independently from the other stages. So it has some more complex logic there. But conceptually it's pretty simple as well. So let's go back to the scheduler loop. So we'll have different execution schedule. It'll create the execution schedule based on what the execution policy is. And then it will get stages to schedule. And it will start scheduling. Then as the stage completes, it will update the stage linkages to say oh, this dependent stage has completed or it hasn't completed, because you have to know if something, you have to know something completed, so you know when the stage is done or when the section is done. It's possible that you can be blocked for a variety of reasons, so it logs some of those reasons. If it's waiting for a source, if the split queues are full, which I guess means that it can't schedule more splits yet, because it's still processing. No active driver group. I'm actually not positive what that means. Yeah, so basically we record blocked reasons if there's some reason that a stage is blocked. Then we process all the stages that finished. And then if a stage has finished, then we see if we can pull in more. So we start the loop again. And otherwise, we wait for a state change and then restart the scheduling. And then basically we continue in this loop until all of the stages have been scheduled from all of the sections. And then we complete. Then scheduling is complete. That's basically it. Oh, I wanted to also look at the node scheduler. So the node scheduler we create our node selector so we can to decide which nodes to assign tasks to. And we have a few different configurations. There's use network topology, which if you have your disk and compute co-located, then it can take advantage of that by scheduling work close to where the source tables are. So that's the network topology, and that uses the topology aware node selector. And then there's the simple node selector, which is what most cases will use. And then we also have this simple TTL node selector, which I think basically what it does is we use it for elastic compute clusters where some nodes are expected to go away. And then we schedule on, we don't schedule things on nodes that are about to disappear. So we can look at that in a second. So we can look at that. So it basically will go through, get the estimated execution time remaining. It filters which nodes are eligible, and then it based on this is TTL enough, and then it will select from among those nodes. The simple node selector has also a few different configurations related to it. So when it computes the assignments of which node to schedule to, it's it can be either totally random, using all of the nodes in the cluster, selecting from them, or we can use the hard affinity or soft affinity, which is used in cases where you have caching. So either you can say only schedule where I know that I have, some cache related to this query, or soft affinity, where you say prefer to be able to use the cache, but don't, but also allow other nodes. So this would allow for cases where if you have, some table that's being accessed a lot, then you might have one node that gets very busy if everyone is trying to access that same, the same cached, the same cached fragments. And so with soft affinity, we can take that into account and distribute the work a little bit better. And then no preference is the default case, where you're not using any caching or anything, and it'll just make a random selection.
Can you dynamically change the policy? This hard affinity or soft affinity, or is it a static?
Configuration based. So you can choose your configuration, which affinity you want, and then it will be decided based on that.
So it's static. You can't change it dynamically, right?
No, is it per query though?
It means per query you can set. So I don't know what. So I think all the Presto configuration can be mostly, most of them can be chosen at query level or cluster level or session level or whatever, or source level. So
Got it.
So basically you can set the caching on for wherever the queries you feel like it would benefit, then you can set the soft affinity. For the others where you feel the caching might do actually the harm than benefit, then you can leave it default.
Makes sense.
I think that was basically the overview that I had for the scheduler. I don't know if people have questions or something they want to dive into more.
Is there a system table where we can look at the catalogs that map to a particular node? Currently, if you look at the system.runtime nodes, it just gives you what nodes and the node ID, right? Can we even know what catalogs are supported on those nodes? Just to see if there's a catalog mismatch. So sometimes I want to know if there's an issue with the setup, and I'd like to know if.
Yeah, I'm not sure if we have that. I think we just sort of assume that the setup is correct, that all the catalogs are on all the nodes. But I don't really know where the system tables are.
Yeah, I'm not aware of either. I don't think we have it. But that should be pretty easy to find out from the deployment, right? Don't know why this is.
How do you this is an experience I had. I was new to Presto and I set a catalog name wrong, and I didn't realize one of the node was not being scheduled on that node for some time. And yeah, obviously I think if you're experienced, you would know from runtime and so on. But yeah, for beginners, it would probably.
in that cluster, like all the nodes would have the similar configuration, or you had?
I was manually setting up my cluster, and then one worker node, I end up like making it wrong, making a mistake. I guess it's a minor case, but I was just wondering it'll be nice in the system table if you can just show what nodes and are subscribed to what.
Probably is not there because that's not really a common case. Like usually all workers have the similar setup. We don't really.
Got it. Yeah.
The Facebook, we don't really have the use cases where different workers are running different catalogs and different setup. Usually they're all the same.
Got
And
it.
I don't see like a need why. That might be the need as well.
Yeah, I guess in a production setting that wouldn't be the case. I agree, but just from development, like I usually have like especially with Presto, right? Like I have one like I set up a different catalog to target some nodes and sort of playing around with multiple nodes.
Okay.
But I agree from a production setting, I think it would be less valuable.
Okay. Anyone else? Okay. If there are no more questions, we can wrap up, I guess. Let's give it like 1 more minute.
So where the HTTP, like the protocol for the worker and coordinator actions, like where does it happen? Like the get status and like all those commands. Page execution. Okay.
Feel like it's in here, but I'm just checking.
Schedule splits. Yeah. Good. You can see get task set status there. Got it.
Over here.
Yeah.
Great.
SQL stage execution. Good. Cool. Thanks for that information.
You're welcome.
Okay. I think like in case of no more questions, I think let's wrap up. This is not the only forum to ask questions, so please reach out through Slack or any preferred medium of yours to ask any more follow-up questions if you have later. Thanks, Rebecca, for the wonderful walkdown.
Thanks, Rebecca.
Thank you.
See you guys later.